Hi guys, back with another video. This time I thought about making a little thermal paste comparison of the three, which I would consider the best thermal paste options on the market you can buy. I will compare them under a normal water cooling situation, talk a little bit about the overall pricing and just thoughts about buying recommendations in general. On the left we have the old and legendary Gelid Solutions GC Extreme, which came out around a decade ago and got a huge popularity in overclocking use soon after it went retail. It comes in a simple plastic blister package and has some advertisements on the front and the back. Then on the right we have the Thermal Grizzly Kryonaut, which came out in 2015 and has also been popular, and it comes in many different tube sizes. Then on the center we have the newest of the three. This is the Kimping Cooling KPx thermal paste, which came out in early 2017 and has a unique blue color. What combines all of these three pastes is that they are all so-called normal silicone-based thermal interface materials. So they are non-curing, non-conductive and non-corrosive. So they have excellent compatibility with all types of coolers and heat sinks, and they don't conduct any electricity compared to products like liquid metal, so they are very safe to use. Each of these three come with a plastic applicator, which you can see with the GC package here, to help spread the thermal paste. The Kryonaut comes with additional tube heads to help spread the paste. Although I have never really used these, I always use the manual plastic applicator, but the option is there if you want to use it. Both the Kryonaut and the KPx come in a fairly simple resealable package. Only the Kryonaut has the thermal conductivity rating stated on the package, which is 12.5 watts per meter Kelvin. The GC Extreme I checked online, it is 8.5 stated on the paper, and there's no value mentioned at all for the KPx, but hey, those are just paper figures. We always have to test the products ourselves and see what are the actual what is the actual performance in use. Each of these three have very good properties under sub-zero temperatures, so they have been very popular among extreme overclocking guys, and they have very good resistance to thermal paste cracking, which is a huge issue with some CPU generations, and they also remain good in thermal conductivity even in different types of temperatures, so those are very good points about these thermal paste products. And then about their pricing, I will use myself as an example here, what it would cost for me to buy these if I just use the normal retail channels. The best, the most available one is the GC Extreme, as it has been around for so long. It comes in two different sizes, in 3.5 grams and in a 10 gram jar. The 3.5 gram tube for me here in Finland would cost 8 euros, and therefore the price per gram would be 2.28 euros, which is quite okay. The 10-gram jar is not available here, but I used the price I could find from Central Europe. The 10-gram jar is easily available for slightly under 20 euros, so it's 19.9, and therefore the price per gram would be slightly below 2 euros, which is very attractive. The Thermal Grizzly Kryonaut comes in many different tube sizes. It starts around 1 gram, and the highest option is a 37-gram tube. Yeah, now many would ask, what is the purpose of a so high, of a so large thermal paste tube? But you have to remember that there are many different types of people out there, different types of users. If you are just a normal, very simple PC builder, if you only build a PC every 5 years, you only have to make one proper thermal paste application every 5 years. But if you are a person like me, I have been testing a lot of hardware frequently with different types of coolers. So my overall thermal paste consumption has been quite high the last few years. So the 37-gram tube is a good option for a person like me. But when talking about the Kryonaut prices, if I wanted to buy the 1 gram, the single gram tube here, it would cost me 6.9 euros. So then the price per gram would be very high, obviously. The second option is 5.55 grams, and that would cost me 17.9 euros. So then the price per gram would of course drop a bit. The probably most attractive option for most users is the 11.1 gram tube, which for me would cost 24.9 euros, and then the price per gram would be only 2.24 euros, so significantly lower than the 1 gram option. The 37-gram tube, cheapest option where I could find it, it was slightly over 74 euros for the 37-gram. So the price per gram would be pretty much exactly 2 euros. So then that's pretty attractive. It's at the same level as the GC Extreme 10-gram jar. When these are retail channel prices, not any special offer like the hardware bot extreme overclocking community special price on the 37-gram tube. But then about the Kimping Cooling KPx, the very bad feature about this thermal paste is that it's not well available here in Europe. The only real retailer that has it listed still is the Alza from Czech Republic, but recently they stopped shipping to many countries in Europe, so they only ship to a few selected countries. So right now in most places, in many places in Europe, the only place to really buy this thermal paste is from Kimping Cooling itself, which is located in Taiwan. And the sad part of that is of course that since it's coming from outside the EU zone, if it gets stuck in the customs, you also have to pay the value-added tax of your country on top of the product, including the shipping cost. So you have to take the prices that are listed at kpc.com and add, let's say, extra 20% on top, depending on which country you live in. But the thermal paste has been listed for a very attractive price recently at Alza, if you are living in one of the selected countries. The KPx comes in 3 different sizes. It comes in a 3-gram tube, so it's almost the same as the more common GC Extreme. The The second option is a 10-gram jar, and the third option is a 30-gram jar. So it's almost the same size as the largest Kryonaut. 30-gram option is not listed at the moment at alza.com, so we have to move on to the campingcooling.com prices. At the KPC website, the 3-gram, the smallest tube option, is listed for $12 US, so it's $4 per gram, and using the current conversion rate at the time of making this video, the gram price for the 3-gram tube would be 3.5 euros. So it's, yeah, it is higher than what is listed at Alza, but Alza has a very special discount price at the moment. So the 30-gram jar, the largest option at kpc.com, is listed for $42 US, and when converted to euros, it's 37 euros. And when you calculate the price per gram, it's only 1.22 euros. So it's really attractive gram price compared to the GC Extreme or even the Kryonaut. If you live in the US, you will have a bit more luck, as the pastes are listed in both Amazon and Performance PCs, at least, with pretty much the same prices as at campingcooling.com. But yeah, if you live in the EU zone and you buy from KPC, you have to add the value add tax on top. But even then, if I add 24% to the 30-gram jar, the price per gram is still just over 1.5 euros. So it's still pretty good. And of course, the prices vary a bit, as I said before, depending on where you live. But these are just some guidelines. Right then, on to the topic of how to apply thermal paste. If you ask me, the way to apply thermal paste is a lot about personal preference and perhaps even superstition. The basic principle behind the use of thermal paste is very simple. It acts as a thermal interface material between the source of heat, which is the CPU in this case, and the bottom surface of the cooler itself, which is the CPU water block in my test scenario, to remove any possible air gaps between those two surfaces, as even the most flat surfaces are always a little bit uneven at the microscopic level, and thus to get the best thermal performance, we have to cover the entire CPU IHS with thermal paste to get even contact to the cooler, and thus getting the best thermal performance from the CPU to the cooler itself. When I see new PC builders and users in general, I still often see the old guideline to only use a pea-sized dot on the middle, or even a rice-sized dot on the middle, and let the pressure of the cooler spread it. But I can tell you that is not enough in today's standards. Firstly, we have different types of thermal pastes on the market. Some spread easier than others. For example, some of the old brands like the Arctic Silver 5 or Arctic Cooling MX2, they spread really easy compared to some of the diamond-based thermal pastes. And then secondly, we have many different CPU options on the market with different sized heat spreaders. We have the so-called mainstream CPUs like the Intel 9900K in this case. Then we have the Intel X299 CPUs like the 18-core 7980XE or the 10-core 7900X. But then also we have the AMD Threadripper CPUs, which have a huge integrated heat spreader compared to these so-called mainstream CPUs. And you cannot cover an IHS of a Threadripper sized CPU with just a pea-sized dot on the middle. Now, of course, some of you would say that most of the actual heat is coming from the center of the IHS, as we have seen naked deleted CPUs over and over again. Yes, that is true to some degree, but to get the best theoretical thermal performance, you have to cover the entire IHS with thermal paste. And if you only use a pea-sized dot on the middle, the common result is that the pressure of the cooler only generates like a round ball of thermal paste on the IHS, and usually the corners of the IHS are not covered by thermal paste, and therefore you are losing some potential cooling surface area. So the way I usually do, and also because now I often use thermal pastes that come in a jar rather than in a tube, I always use the included spreader that comes with every thermal paste we are testing on this video. So if the thermal paste comes in a jar, I just manually extract some from the jar and wipe it all over the IHS until the whole IHS is covered. But if I use a thermal paste that comes in a tube like the GC Extreme or Kryonaut, I just put an ample amount of it on the center and just manually spread it until the IHS is covered. Now, another thing, you cannot really put too much thermal paste that would cause any harm to your cooling performance. Of course, yeah, you could extract the whole tube of thermal paste on the IHS and it would create a huge mess. But if you put a bit too much of thermal paste on the IHS, all the excess will be pushed to the sides by the pressure of the cooler. So you cannot really put a bit too much thermal paste, as all the excess is pushed out anyways. But on the contrary, if you use too little thermal paste, as in, for example, using a right-sized dot on the middle, you will not get the full thermal contact between the two key surfaces. So the key really is just to have a thin layer of thermal paste that covers the entire source of heat. So the way we'll be doing in this test scenario is that we are just putting a blob of it on the middle like this, and then spread it with the included spreader. Of course, when you are ready to apply thermal paste, always make sure that both the surface of the CPU as well as the surface of the cooler is well cleaned from any old thermal paste remains. I often use windshield alcohol combined with the CRC electronic cleaning spray. That combination works really well for me, and I've been using it for years. And once you are sure that the both surfaces are clean, you can apply the thermal paste like I just did. Then we are pretty much ready to assemble the cooler and get the system going on. So I'm going to test the temperature result of each of the three thermal pastes by running the Intel Core i9 9900K on the Z390 Dark with all cores and threads at a speed of 5.3 GHz with 4.8 on the cache, and with a relatively nice daily configuration on the memory. So it's 4133 megahertz frequency with 16, 17, 17, 28 command rate 2 timings with set V-core value of 1.3 volts. The CPU-C isn't reading the V-core value correctly on this motherboard, and it's only reading the CPU VID, which is a CPU dependent stock V-core value pretty much. But the real V-core is slightly over 1.3 under load due to load line calibration, so the real value is around 1.308 or 1.31. We will test the temperature by running the Prime 95 26.6 version, so the non-AVX version, in a small FFT mode for 30 minutes with each thermal paste, and compare the average value of the core maximums measured by core temp, and compare that value to the ambient temperature, which we are measuring here with a K-type thermocouple. We will let the test run for 30 minutes with each of the thermal pastes. It's currently running with the Kimping Cooling KPx, and once we stop the test, I will mark down the end ambient temperature value, as while we run this test the room temperature starts to go up slowly, as all of the heat from the CPU is dissipated into the room air, and that way we can measure the accurate delta temperature value. Right then, on to the conclusion. The short answer to my overall testing is that they are pretty much identical products. I was really amazed to see how close the temperature results were, considering the large difference in thermal conductivity rating between the Thermal Grizzly Kryonaut and the GC Extreme. The overall temperature differences of the three different thermal pastes were only within a half a degree compared to the ambient room temperature. So it's nearly impossible to point out the clear winner of the three, as the results are pretty much within the margin of error. And it also shows that you should not be looking just at the thermal conductivity figures that are written on the packages, as the Kryonaut had around 50% higher thermal conductivity rating than the GC Extreme, yet it lost to GC Extreme by 0.2 degrees compared to the ambient room temperature in my testing. So you cannot really only rely on the package figures when choosing the correct paste you wish to buy. Of course, liquid metal would beat all of these so-called normal thermal pastes in ambient-based cooling solutions, but I generally do not recommend using liquid metal on top of the CPU IHS, nor between the GPU and the GPU cooler, as in liquid metal easily leaves quite permanent marks on top of the CPU IHS, and it can cause issues if you ever have to RMA the CPU back to the store or straight to Intel or AMD. And it can also cause issues if it hardens over time between the GPU and the GPU cooler, and it can even short something if it accidentally spills onto any of the components around the GPU. And the temperature gain in both of these applications is actually quite minimal over a high-end normal thermal paste like what we use today. But the situation is totally different if we talk about CPUs that are not soldered, and when we have to delete them and use our own solution between the CPU IHS and the CPU die itself. There, liquid metal has a clear advantage over the normal thermal pastes, and you must use liquid metal to really get the best thermal performance of the whole solution, and even make the deleting process worth the risk. But in general, I think all of the three different thermal pastes I tested today are great, and I would happily recommend any of them for any PC build. Price is of course a key factor, and it's quite obvious that a normal user does not easily order just one small tube or one small jar of thermal paste from, let's say, Taiwan, as the shipping cost is already quite high for just a small item like this. And it causes extra annoyance to wait for a key component before one can build the rig, and the shipping cost plus the value-added tax makes the saved money in gram price go in vain pretty much. So I really hope that Vince, aka Kimpin, will make the KPx more available here in Europe, since also stopped shipping to many European countries. So we really need some other distributor now to really bring it to the retailers. But luckily, both GC Extreme and Thermal Grizzly products are well available, so you can choose either of the two. But even so, I really like all of the three different thermal pastes. So far, as I've tested many components on sub-zero cooling applications as well, I've had the best results when it comes to thermal paste cracking with the KPx. It does seem to have the best resistance to thermal paste cracking, but of course every thermal paste will crack eventually, but usually it's the lower end cheaper options that are not designed at all for sub-zero cooling applications that crack the easiest. And all the three we tested today, so GC Extreme, Kryonaut and this, they all have very good properties on LN2, and they can run full pot quite easily. Also some other users like Dancup, Splave and Roman also compared many different thermal pastes on LN2 applications, and they had the best results with both GC Extreme and Kryonaut. KPx is of course the newest option to the list of thermal pastes, so it's not it hasn't been reviewed and compared that much. Other than that, if you like this video, please like and share it again, and subscribe to the channel, and see you next time.